Welcome back, everyone. So we're going to start off with just a little bit of review, talking about logical strength off the hop. So last time we were talking about trying to separate out logical strength from having true premises, right? We've been talking about this relation between premises and a conclusion, the inferential relation, the justification relation, or the reason to believe relation. These are all kind of synonyms for the same thing. Basically just the premise is supposed to make it more likely that the conclusion is true, assuming that the premise is true. And that assuming part is crucial because we can know that the argument has good logical strength without knowing anything about the truth or falsity of the premises, right? Those are two totally separate things, the logical strength of the argument and whether the premises are true or not. So we talked about the most extreme version of logical strength, that is the maximum amount of logical strength you can have, which is validity, and is the kind of guarantee that you're really not going to get in any other part of your life. Very few things in life are guaranteed, but if an argument is valid, sometimes we say deductively valid, then it's, if those premises are true, then the conclusion is guaranteed to be true. There's no possibility that the conclusion is false while the premises are true. Almost all the arguments you're going to see in your life aren't deductively valid. We might say that they are inductive arguments. They might have good inductive strength. Let's keep the word, people use this word validity differently in different parts of the world, but let's keep validity just for that deductive thing. And we'll just talk about the strength of the argument, the inductive strength of arguments that are, while they're not guarantees of the conclusion, they're still reasons to believe the conclusion or something like that. And then we talked a little bit about soundness. Soundness is what you really want. Soundness is when you have a valid argument and the premises are true. And in that case, the conclusion is guaranteed to be true. Yeah? Okay, so that's what we were talking about last time. I showed you some argument forms. It's a sort of pattern of reasoning. And we can test the validity of some arguments by seeing whether they fit argument forms. Let me show you these argument forms again with some diagrams. I think these help to sort of visualize what's going on in the argument forms that I showed you. So last time I showed you two valid argument forms and two fallacies, right? So modus ponens, the most classic one. All ducks are bird, Jerry's a duck, therefore Jerry's a bird, right? So if this circle is the set of all birds, and this set is the set of all ducks, and here's Jerry, you can tell for sure that Jerry's within the bird circle, right? Given that Jerry's a duck, yeah? Logically speaking, there is no possibility that Jerry's gonna be a duck without also being a bird, right? And just in the abstract, all y's are x's, so all of the members of the class y are members of the class x, and we know that J is a member of the class y, therefore it's an x. Yeah? Okay? Modus tollens, also a valid argument form. So if you see something of this form, you know for sure that it's a valid argument at least. All ducks are birds. Jerry's not a bird, therefore Jerry's not a duck. So Jerry's outside of this circle, the set of all ducks. Therefore, you know for sure that Jerry's not in the circle of, he's outside of the circle of birds. Therefore, you know for sure he's outside the circle of ducks. And again, we can do this in the abstract. All x's are y's. Sorry, that's backwards. Should be all y's are x's. Yeah, sorry, that's backwards. Should be all y's are x's. All members y are all things in the class y are members of the class x. And J is not an x, therefore, in this case, so it should be J is not a y, therefore J is not an x. My apologies. I got this slide backwards. I will fix this and repost the slides after class so that it makes sense. You can, if you just ignore my mistaken words on the left, you can see how this inference is going to work on the right, right? So if J is excluded from the class of x's, you know J is also excluded from the class of y's. Okay, now contrast those with the two fallacies that we saw last time, affirming the consequent. So here, I mean, the fallacy itself isn't sort of super visually obvious. I hope those two valid argument forms were just super visually obvious how they work. Here, we have to sort of imagine alternate scenarios. So all ducks are birds, Jerry's a bird, therefore Jerry's a duck. call this affirming the consequent for reasons we'll talk about in a little bit. So I guess in this case you can see how it's totally possible that all ducks are birds. That's true, I think. Jerry is a bird, let's suppose that's true. But it's not true that Jerry's a duck when Jerry falls outside this circle, yeah? So again, when we're separating out logical strength from the truth of the premises, it could be true. So when you have a fallacy like this, it could be true that all birds are ducks and Jerry's a bird and Jerry's a duck, right? All three of those could be true. Nonetheless, if it's in this form, it's a fallacy, right? Because the truth of the premises doesn't tell you whether the conclusion is true or not, right? It's not informative. And what premises are supposed to do is inform you about the conclusion. Another one, denying the antecedent. All ducks are birds. Jerry's not a duck, therefore Jerry's not a bird. Again, those two premises can be true without the third thing being true as well. And the premises really aren't informative about the conclusion. They don't give you a reason to believe the conclusion, therefore it's a fallacy. Yeah? Did I get this one right? Okay, now it's time to do some critical thinking and decide whether I got this slide right or not. Does that look right to you? Okay, all x's are y's. Or sorry, all y's and x's. So no, I did not get this one right. All y's are x's, and j is an x, therefore j is a y. That's a fallacy, because j can be an x without being a y. Yeah? Okay, so those were those argument forms, and just a reminder, there's like a million of these things. These are the most classic standard ones. They come from like Aristotle. And we'll look at a handful more throughout the semester, but I don't want to put too much stress on this. I want you to learn these ones in particular so that you get adept at using what I'll talk about today, which is categoricals and conditionals, because those are going to be important for the skill of argument mapping, which is more or less what we're starting today. So, just a note on what this relation is supposed to be, this inferential relation or the justification relation. Philosophers often talk about truth preservation. So the job of a good inferential relation is to preserve the truth of the premises. So if you put in true premises, you get out true conclusions. Yeah? Now, if you don't put any truth into the truth-preserving relation, you don't necessarily get any out, right? So you don't get the guarantee of the true conclusion if you don't put in true premises. But if you do put in true premises, a good inference is supposed to preserve that truth value. Yeah? So that's what a strong inference does. And a deductively valid argument preserves 100% of the truth value. So if you put in true premises, the conclusion is guaranteed. Inductive arguments, or less than perfectly valid arguments, can preserve, let's say, most of the truth value. And by that I mean, I don't mean that the conclusion ends up being just mostly true. It's just less likely to be. It's not perfectly guaranteed to be true. So what's diluted is the guarantee, something like that. Does that make sense? Yeah. Okay. And we talked about how you can perfectly well have false premises and a true conclusion. You can also have bad inferences. So this arrow might be the justification relation might be just terrible, and nonetheless, the conclusion ends up being true. So bad arguments do not mean, so just because somebody's made a terrible mistake in their argument, they've given you a bad argument, an invalid argument, or fallacious argument, doesn't mean their conclusion is false, right? You can make bad arguments for true claims. Yeah? Okay. Something that we should sort of note here is, I want to, right off the hop, I would like you to think for a minute about premises and their role in an argument. And this relates to what I've mentioned a few times now about the difference between an argument and a fight. So in any given argument, I think it should be, so sometimes we give a premise to justify another premise. Some people call the middle thing a sub-conclusion. That's okay. In this class, let's just call anything that's not the conclusion a premise. Is that okay? So usage differs on this. For the sake of this class, anything that's not the very end thing is a premise, and the very end thing is a conclusion, right? So in that sense, you can justify conclusions. You can give a reason to believe something that's being given as a reason to believe something. But it should be clear looking at these diagrams. I mean, one of the nice things about thinking about these diagrams is the fact that it makes vivid that there are always, in an argument, unjustified premises. Always. Because, why? What would happen if you tried to justify all the premises in an argument? Yeah?
You would have to justify your justifications from them, and then it would just go on
infinitely. Exactly. So an argument with all of its premises justified would be infinitely long, right? You would need a premise to justify that premise, and another premise to justify that premise, and on and on and on for infinity. Obviously, we don't want infinitely long arguments. We want arguments that you could present and read in a single human lifetime, right? So there are always unjustified premises in an argument. Always. This is just saying that thing about subconclusions again. Now, what that means is that the premise, whatever the top level premises are in the argument, are being presented, and the person's just hoping that you believe them, right? So those top level premises are being offered as kind of, hopefully, common ground, right? If there's no top level premises that you can agree on, you can't present somebody an argument. Every argument, in this sense of argument, has to start from some point of agreement. Otherwise, you're not making an argument, because an argument is one idea presented as a justification for another idea. If there's nothing that you can agree about, you can't present an argument to somebody. The best premises are the kind that everybody would agree on. So really strong arguments start from the least controversial premises, premises that you and whoever you're talking to will quickly agree on. You say, okay, yeah, that sounds right, right? Now, that's why arguments always have to, they logically require, on pain of infinite regress, some level of goodwill and cooperation. Yeah? If you're talking to somebody who's going to fight you on every single point, that is, there's no top level premises that you can agree on, you're not having arguments. You're having a fight. Right? And there are people like this. There are people who just derive so much joy from being contradictory that they will refuse to agree to anything. And you can't have an argument with you can have a fight with that person, but you can't have one of these. You cannot present arguments, because arguments start from agreement. And the techniques that we're learning here are mostly techniques to try to maximize agreement, try to maximize the parts of the discussion that you don't have to wrangle over. Yeah? So keep that in mind when you're thinking about arguments in general. All arguments just logically require, for them to be effective, something that you agree about. All arguments contain unjustified premises. Those are the bits that you're hoping the other person agrees about. Keep this in mind when you're writing essays and eventually your argument analyses. One of the most common critiques I see in undergraduate essays is, you've got some piece of writing that you're critiquing, and you say, well, I don't think this is a good piece of writing because the author didn't justify this premise. And that's just kind of a unless there's some good reason to doubt the premise, that's just a misunderstanding about how arguments work. Every author who's ever presented an argument includes unjustified premises. That's not a problem. That's a feature of every single argument. Yeah? So it's a pretty weak critique. To say that the author hasn't justified a premise is a pretty weak critique unless you've got some reason why you should doubt that premise. So premises do their job by being things that people are likely to agree on. So if somebody presents you a premise that's wildly implausible, that most people would disagree on, then that's a real problem. You say, I think this is a bad premise. It's not doing the job of a premise, which is to be something we can agree on. That's a valid critique. But just saying they haven't justified a premise is kind of no critique at all. Yeah?
If they try and use like a premise that's more like controversial,
Mm-hmm.
then would that be something where they would almost need to justify it?
That's right. So that's them misunderstanding what a premise is for. So if somebody presents to you, I mean, the classic example is you should believe the contents of the Bible because God wrote it and it's all true. You say, well, the first thing is more controversial than the second thing. So you definitely don't want to use that as a premise in that argument, right? So presenting a premise that's more controversial than the conclusion is a deep problem with the argument. Its premise is not doing their job of being points of agreement. Yeah. So a controversial premise, an undefended controversial premise, is a problem with the argument. But just having not justified a premise, that's not a problem. Or at least, if it's a problem for every argument that any human has ever written. Yeah? Okay, good. Okay, so, I mean, you can have this middle premise might be controversial. That's okay, right? Because you've given something to justify it. You've given some reason to believe your controversial premise, which is then justifying your conclusion. So that's fine. It's just these top-level premises that there has to be some level in which you're presenting things that are unjustified. In mathematics, it's axioms or something like that, right? Okay. Okay. That's it for review. Now we'll move on to new stuff, yeah? So let's start talking about argument mapping. And we've sort of started this. We've seen the simplest possible argument, which is just one premise justifying one conclusion. We're going to get deeper into this. We're going to start today talking about more complex structures where there's more than one premise justifying a conclusion, different ways that premises can relate to conclusions. Before we do that, let's talk a little bit about why we're bothering with this at all. So recall last time we talked about inference indicators, and we saw that they could be arranged in a variety of different ways, right? So here we've got an argument, the check engine light is on, therefore my car needs work. We could write that a whole bunch of different ways. So the check engine and light is on, therefore my car needs work. My car needs work because the check engine light is on. The check engine light is on, my car needs work, right? So no inference indicator at all. And you know, the way that those first two are written is flipped, of course, right? The order in which they are presented to you can be reversed. But all of three of those are captured by this one argument diagram. So the point of these diagrams is in some sense to get beneath the surface of the writing. So the written word is usually ambiguous in a whole bunch of different ways. The order in which it's written is not necessarily the order in which things are trying to justify each other. The ideas might be presented, you know, the conclusion can come first, it can come last. Sometimes it appears in the middle. The premises don't necessarily follow they don't always start from the very top level premise and then work their way down. It would be tedious to read writing like that. You don't want people to write like that. You want them to write sort of naturally in a way that flows rhetorically. But these argument diagrams, their job is to sort of get beneath the flow of rhetoric, get beneath the way it's written, and to really try to dig into the logical structure of the argument. Remove a bunch of the ambiguity and sort of get clear on what's supposed to be justifying what. Yeah? So that's kind of the point of this practice, to learn how to dig underneath the surface of the writing down to the logical structure. All right? Okay, so today we're going to talk about two different ways in which premises can be related to a conclusion. So far we've seen there are kind of three, with just one premise and a conclusion, of course. Here's two slightly more complex ways, dependent and independent reasons. And we're going to, as we go along, we're going to represent them in these ways. So premise, these two premises are independent reasons. We're going to have two separate arrows. If we're going to represent dependent relations, we'll draw a line under the premises and have one arrow. So let me tell you what this means, and then that'll be relatively clear. So start from independent reasons. We've got two premises, both justifying a conclusion. So here's an example of two independent reasons for meaning to justify the conclusion of an argument. Conclusion is you're a bad roommate. Here's one independent reason, you don't clean your dishes. Here's another independent reason, you haven't paid your rent. Okay, so what makes premises independent is that their logical relationship to the conclusion doesn't depend on the other premise being true. Okay, so what we do when we're testing for dependence or independence is sort of mentally block out the other premise. So let's talk about you don't clean your dishes. So what we do when we're judging whether these are dependent or independent, we just sort of block out the other premise and ask ourselves, is this still relevant to the conclusion? So is failure to do dishes a reason to believe that somebody's a bad roommate? Yes. I'm sorry to say, if this is news to you, I suggest you rush home and do your dishes. But yeah, that's a reason to believe. It's not conclusive, of course. Maybe you are otherwise a very charming, sweet person. You do all of the other stuff. You're very nice and nice to be around. Maybe this is just your one failing as a roommate, that you don't do the dishes. But that is nonetheless raises the probability that you're a bad roommate. Similarly with the other, and that doesn't have anything to do with whether you're paying the rent or not, right? The relevance of you doing the dishes is totally independent of the relevance of you paying your rent. Similarly, failure to pay rent, maybe you do your dishes, maybe you're otherwise wonderful, but failing to pay rent is at least evidence that you're not really living up to the roommate deal, right? Okay, so the independence of these is about whether you can totally ignore, block out, pretend the other one doesn't exist, and still ask yourself, is the premise I am looking at relevant to the conclusion? The conclusion is the cat is sick, and if she hasn't eaten her food, that's evidence that she might be sick. Not conclusive again, this is not a deductive argument in any way, but it is inductive evidence, right? It should raise the probability in your mind the cat is doing poorly. Similarly, she won't play with her toys. So maybe she's eating fine, she won't play with her toys, she might be sick. Maybe she's playing with her toys, but she's not eating any food, she still might be sick. So together, these give better evidence than either of them alone, right? Like the combination of the two premises is a stronger argument than either premise individually. That's not what makes them independent. What makes them independent is that this arrow still works even if this premise fails. Yeah? So suppose this is false. Suppose actually, it turns out the cat is eating her food. This arrow is still preserving truth, right? It's still leading to the conclusion. So, to put it formally, two premises are independent if the relevance of one to the conclusion doesn't depend on the truth of the other. If it turns out that one of the two independent premises is false, the other can still be a reason to believe the conclusion. Yeah? It's nice to have arguments structured this way. So, you want to present robust arguments, arguments which would still work if part of it fails. So independent reasons are sort of robust against the failure of some half. Like half of this argument could fail, the other half still works. Yeah? Okay, so that's independent reasons. Contrast that with dependent reasons. So in dependent reasons, all that stuff I just said is not true. So here's a dependent argument. All men are mortal. Socrates is a man. Therefore, Socrates is mortal. Now, if one of those top two premises turns out to be false, the other one no longer leads to the conclusion. So suppose Socrates is in fact a man, but we figured out the cure for death and now everybody's immortal. Now it no longer, so that all men are mortal turns out to be false. Well, now that conclusion no longer follows at all. This Socrates is a man is 0% evidence for the conclusion, right? It doesn't raise the probability at all. It's not relevant anymore. Yeah?
What if it was like most men are moral?
Well, that would be still it's still dependent, I think. If it says most men are mortal and Socrates is a man, so if it turns out to be false that most men are mortal, then Socrates being a man isn't relevant to the conclusion anymore, right? Yeah? Okay, good, good. Yeah? Or those who hesitate are lost. You hesitated, therefore you are lost. So, I don't think it's at all true that those who hesitate are lost. I think hesitating is a smart thing to do a lot of the time. Take a minute. Take a couple breaths. Figure out what you're going to do, right? So the fact that you hesitated really isn't evidence that you're lost at all. Sometimes it's evidence that you're a thoughtful person who takes a minute to decide what they're going to do, right? So those two things need to both be true to entail the conclusion. Yeah?
Are we ever going to have to infer one of them? So if you just wrote those who hesitate are lost and then say you are lost, are we supposed to infer that you hesitated? Or are we going to say if it's not stated that it's not okay?
That's a good question, and you will have to do some of that. So what we're going to talk about is missing premises, because very often in an argument, people don't say all of the things that they intend as premises. They just leave some implicit. And when we're reconstructing these things in terms of argument diagrams, we'll want to sort of pick up on where those things are. So you will have to do some of that. Students last semester found that one of the more challenging parts of the course, they didn't like missing premises at all. Hopefully I can make it better this time. I don't know. Okay, so yeah, you will have to do at least some of that. It's hard to infer missing premises because you have to sort of guess what the person's thinking. And we're doing this mostly out of context, so it's tough to guess. But we'll talk about today a technique that we'll use to detect dependent relations between premises, and you can use it to reconstruct missing premises. So there'll be some rules you can use to sort of guess how to reconstruct missing premises. Yeah. Okay. So in sum, two premises are dependent when they both need to be true in order for them to be relevant to lead to the conclusion, in order for either to be a reason to believe the conclusion. Yeah? So if it's false that you hesitated, the fact that suppose is true that those who hesitate are lost. If you didn't hesitate, that has no bearing on whether you're lost or not, right? It's not just that it's a weaker, and I want you to distinguish this from independent reasons. It's not just that it makes a weaker argument. It's not like when you lose one of these premises, what you're left with is still half an argument. If you lose one of those premises, you've got no argument at all. Yeah? You're not getting anywhere. If it's a dependent relation and you lose one half of it, you get nowhere. Whereas with an independent argument, reasons, you lose half of it, you still have half an argument left. Yeah? Okay. Right. So yeah, that thing. Okay, so here's the technique. Here's what I recommend for trying to detect dependent relations. We'll call it the puzzle piece method. So dependent premises will typically have a shared element that drops out of the conclusion. Let me show you an example. So those who hesitate are lost, and you hesitated. Those are dependent. And what's shared between those two premises that gets lost in the conclusion, that drops out? There's a concept that appears in both premises and doesn't appear in the conclusion. Yeah?
Is it almost like you're canceling out the hesitating from each side?
The hesitating, that's right, yeah. So it's like the hesitating gets crossed out and you get just the remainder left over. So it's like this, see there's this sort of surface between the two puzzle pieces. So this shape and this shape, where the two pieces meet, that disappears when they're combined. Yeah? So that common element, and for the puzzle pieces to fit together, have to be the same shape, right? So there's this common element between both of the premises in a dependent relation that disappears in the conclusion. There's another one. All dogs are friendly. Gonzo is a dog. Therefore, Gonzo is friendly. Can you see that this is a dependent relation? So if it turns out, so all dogs are friendly, let's assume that's true. If it turns out that Gonzo is not a dog, Gonzo is a parrot, then the premise all dogs are friendly gives us exactly no evidence about whether Gonzo is friendly, right? Like zero. So they are dependent, and there's a shared bit between the two premises, which is, what's the concept that appears in both of those dependent premises? Dog, yeah. It's not a trick. It's just the thing that appears in both. So dog drops out, and we get Gonzo is friendly. Yeah. So dependent premises, you can do this. If you can do this with the dependent premises, with two premises, they're very likely to be dependent. Yeah. Whereas compare that to our independent thing. There's nothing like, if you look at this premise and this premise, there's no shared thing that drops out, right? There's no shared concept between the two premises that fails to appear in the conclusion, right? It's not just like we're sticking these two premises together and losing the shared bit. They're just separate, unrelated ideas. Yeah? So if it fits this puzzle piece thing, you've got a good chance that those are dependent premises. Okay? Okay. This puzzle piece method comes from a lovely little series of videos by Donna Warren from the University of Wisconsin. I put a link on Blackboard to her videos. There's like 6 of them about argument mapping. She's lovely and carefully explains things very, very nicely. So if you're confused about any of this stuff, I would recommend checking out those videos. They're kind of old and like homemade, but like she's really good. And everything in those videos is I'm endorsing for this course. There's one difference between her presentation and mine. She calls the middle, if there's one premise justifying another premise justifying a conclusion, she wants to call this middle thing a sub-conclusion rather than a premise. That's just a sort of terminological difference. That's the only difference, okay? So, recommend those if you want to kind of, basically she's just going to go over the same material in slightly different words, but that actually helps sometimes. So, okay. Okay, so there's dependent and independent reasons. Any questions so far? What questions have you got about this? Why are we bothering with this? What's going on? Are we okay with this? Okay, so when you're mapping arguments, this is the primary distinction between the two types. There's 2 basic types of justification relation that we're going to talk about. One is these independent relations and one is these dependent relations. This sounds, I hope it sounds simple. This is hard to do. What's hard to do is to take a real piece of writing that's not like, all dogs are friendly, Gonzo is a dog. Like, the way I'm presenting to you makes it blindingly obvious which of these two these are. It's actually really hard to take a real piece of writing that's not written to be analyzed in this way and figure out which of these two relations they are. So we're going to practice this a whole bunch. We're going to practice argument mapping throughout the rest of the semester. And my hope is that it'll become natural and intuitive to you to be able to distinguish these 2 kinds of relations. Yeah? I mean, that's my hope. We'll see. Yeah. Okay. So, let's try it a couple times, shall we? Hunting rhinos, so P1, premise 1. Hunting rhinos is morally wrong. Hunting rhinos is too expensive. Therefore, we should not go hunting rhinos. Are those dependent or independent reasons for the conclusion? Yeah. Independent. Independent. I think that's right. They are independent because we do this test. So here's the test that you should always do. And it's a matter of just sort of mentally blocking out. You say, imagine you'd never read premise 2. Imagine you have no idea that it's there. Sort of mentally put like a dark line across it. Now just look at premise 1 and the conclusion and ask yourself, is that an argument still? Does that constitute a potential reason to believe? Say, yeah, okay, that sounds like an argument. It's morally wrong to do this thing, therefore we shouldn't do it. That's kind of an argument. And now do the same thing with the other premise. Mentally block out premise 1. You say, it's too expensive. Hunting rhinos, big pain. Very expensive, therefore we shouldn't do it. It's not as nice of an argument, but it's still an argument, right? I mean, you might question the morals of somebody who made that argument, but nonetheless, it's an argument. Therefore, these are independent reasons for the conclusion. Okay. A poor diet can lead to stomach trouble. You have a poor diet, therefore you're at risk of stomach trouble. Yeah? Dependent. Good. And what's the shared bit that drops away? So let's try the puzzle piece method on this. Yeah?
Poor diet.
Poor diet, right? So poor diet is a shared concept between those two premises. It fails to appear, it does not appear in the conclusion, but the unshared bits do appear in the conclusion. So stomach trouble and you basically are the unshared bits. You, stomach trouble, shared diet, or poor diet drops away. Good. I see a light on in the window next door. I can hear music coming through the wall. Therefore, my neighbors are home. Shout it out. Yeah. Independent, right? We can block one out. Either one of those would be more than zero evidence. They might have left the lights on and the music blasting just because they're jerks, but probably that's evidence that they're home. Yeah? Okay, good. Okay, so all of these have been, what I've been doing is giving you what are called categoricals. So categoricals are these all X's are Y's statements. All dogs are cute. All squares have 4 sides. Yeah? Okay, so let's call those categoricals. They say something about a category of objects, right? Now, we can go back and forth. There's a kind of equivalence between categoricals and what we'll call conditionals. So conditionals and categoricals are both, they're the main types of premises that will appear in dependent relations. So a conditional is an if-then statement. If this thing, then that thing. And you hopefully can see that there's a kind of equivalence between these two. We can translate between categorical claims and conditional claims. So if something is a dog, then it is cute. And that's really saying the same thing, isn't it, as all dogs are cute, right? The content of those claims are basically the same. Yeah? If something is a square, then it has 4 sides. Really saying the same thing as all squares have 4 sides. So if you've got one of these, you can translate it into the other type of thing. That is assuming, so here's something I'd like to flag early on here. The categorical claims, in order to be able to do this translation, the categorical claim has to be what we call universal. So all is the indicator for a universal claim. All members of this category have this property, is what a universal categorical claim says. So all birds fly. Yeah?
Does no
Yes, it absolutely does. So you can say something like, no dogs are cold-blooded, or something like that. Yeah. In Aristotle's logic, there's a whole bunch of syllogisms that do the no this and no that. Yeah. And remember, actually, modus tollens has one of these as well. So it's like all birds are ducks. Jerry's not a bird, so the negation is in there. All right. So yeah. So here's a funny thing about English. This is not true about all languages, but in English, we can make these claims that are, well, they sound like categoricals, but they're a bit weaker. They sound like universal categoricals, but they're a bit weaker. So if I say birds, so birds fly. Is anybody worried about that sentence? Does that sentence sound true to you? The claim birds fly? No? You don't think birds fly?
Well, not all birds fly.
Well, I didn't say all birds fly. So here's the trick. That's the trick. Yeah? In English, when we do these sentences like birds fly, it's ambiguous. You could read that as all birds fly, or you could read that as generally birds fly. And there's just no marker, there's no explicit marker in English to tell the difference between those, which sense of it you mean. So if I say I think it's true to say birds fly, and that's true because mostly birds do fly. But now I want to translate that into a conditional. If an object is a bird, then it flies. And you bring me a penguin, I said something false, right? So in order to do this translation, so a conditional is like a rule. You know, it says, if this thing is true, then this other thing is also going to be true. That's a rule. It's kind of like a rule of inference. It's like, give me this and I'll give you that. Show me a bird and I'll show you something that flies. So you can translate between the universal categoricals and a conditional, because if all birds fly, then the rule is always going to be reliable. But if you just mean generally birds fly, then you can't do that translation. Yeah? So we'll talk more about that. I think I'll leave that be for now. We can talk more about it when we talk about disambiguating language, because this is going to be a real headache for us. Yeah.
Is one stronger than the other?
That's right. Absolutely it is. So, I mean, yeah, so take, all birds fly versus generally birds fly versus some birds fly. So, and all of these, I would submit to you, can come under if I just say birds fly, I might mean any one of those three. Now, all birds fly is obviously the strongest claim, strong in the sense of you're claiming a lot. So you're claiming to know something about every single member of the category birds, right? It's a very strong claim in that sense. Generally, birds fly, and it is much less strong. All you're saying is, most of them. So if somebody brings you a penguin, that hasn't refuted generally birds fly, right? That's not, just one example of a non-flying bird would disprove all birds fly. You'd need a lot of examples to disprove generally birds fly. And if what you mean is some birds fly, all you need is one example of, or maybe two or three examples of flying birds to make that true. So there's a huge range in the strength of claim you might be making when you make one of these. These are called generics. A generic claim, birds fly, dogs bark, men are pigs. Those are all generic claims. And I'll come back to I can't resist talking about this stuff. I'll come back to this when we're talking about disambiguating language, because language is very often unclear. There's a huge range of interpretations that make sense given the words, And that unclarity is, remember, what we're trying to do is come up with points of agreement. And we're trying to get common ground. We're trying to all get on the same page in terms of what we're saying and understanding each other. And when you're using generics like this, there's huge range for misunderstanding. So someone says to you, men are pigs. And you say, well, Mr. Rogers was a man and he was nice. And their reply might be, well, I didn't say all men are pigs. And now we're just sort of trading in the ambiguity between these readings of the generic. I'm told this doesn't exist in all languages. I'm told that the sentence in Chinese, birds fly, is not a complete sentence. You need to be more, you need to give more details before it's a grammatical sentence. It seems to be probably not just English, but not all languages are like this. Yeah?
So at that point, this turns into equivocation.
So if equivocation is when you treat one word as though that actually has two meanings as though it's only got one meaning. So if somebody does so it would be equivocation if somebody did the following. If they say, men are pigs, and you say, well, Mr. Rogers is a man and he's real nice. And they say, okay, well, it wasn't all men. But then they go on to translate the generic into a conditional, say if somebody's a man, then they're a pig, then what they're doing is using more than one of these meanings as though they're equivalent when they're not. So equivocation would be to shift back and forth between more than one meaning, treating them as though they're the same even though they're not. Now, obviously the best thing to do is just clear up what you mean if you're talking face to face, but yeah?
Out of categorical or conditional, which one is stronger of the two?
So, because you can translate between them, they're kind of equivalent. So a universal categorical and a conditional are the same strength. So this is the all birds fly is the universal categorical. Yeah, so they should be of equivalent strength. Yeah? Okay. Let me check the time. Usually I'd give you a break right now, but I don't think we're going to use up the whole 2 hours. So let's just plow through, yeah? Okay. Okay. So categorical and conditional claims are the kind of claims that are going to end up in dependent relations. So if you say, if it's snowing, then the roads will be slippery. It's snowing, therefore the roads will be slippery. That's a dependent relation, yeah? We recognize this is we can do the puzzle piece method on that. There's a shared part in the two first premises that drops out in the conclusion, leaving just the unshared parts, yeah? Or all dogs are mammals, mammals are warm-blooded, therefore all dogs are warm-blooded. Again, those are dependent. So conditionals, categoricals, those are the kind of things that you're looking out for when you're trying to detect a dependent relation between premises leading to a conclusion. They're not always quite so explicit. So again, I'm quite aware that the writing in these example arguments is clunky and weird. People don't generally write like this. So sometimes you'll have to, in order to see the categorical or the conditional, you'll have to do a little bit of interpretation. You'll have to rephrase it or something like that. And throughout, we're going to do a bunch of rephrasing. So I'll give you an argument, and part of your job is going to be to kind of rewrite it in ways that make the structure of it clearer, while hopefully preserving the intent and the meaning of the premises. So, yeah. Okay. Talk a little bit more about conditionals. So, again, philosopher speak, but I would like you to know these terms. The conditional's got two parts, the antecedent and the consequent. So remember the two fallacies I showed you, affirming the consequent and denying the antecedent? That's about these parts of the conditional. That's why they were called that. So the conditional is an if-then statement. It says, if this is true, then the following thing is true. And the if part is the antecedent. The then part is the consequent. conditionals are weird in terms of their truth value. So, do you think this sentence is true? Does everybody think this sentence is true? If it's raining, then the sidewalks are wet? I mean, sometimes there's awnings, but in general, right? Like, if it's raining, then the sidewalks are wet. Now, it's not raining right now. Is it still true? Yeah. So this is true about what exactly? What would be true? Yeah, yeah.
It's true in situations in which it is raining.
Well, but it's true now.
Oh, I have to look outside, so.
Let's assume that it's not raining outside. Is it still true that if it's raining, then the sidewalks are wet?
Yes.
I think so. I think that's true. So the suggestion was it's true because it was true before. So what about if I rolled down these stairs, I would break a bone? Is that true? I'm very uncoordinated and my bones aren't very strong. Do you think it's true that if I rolled down the stairs, I'd break a bone?
Likely.
Yeah, I think likely. Let's call it likely. I'm not going to do that. Hopefully so I'll tell you for sure I've never done that. Hopefully I never will do that, right? But that conditional is still likely to be true, which is a weird, usually when something's true, it's true because of some actual state of affairs in the world, right? There's some, say, if I want to say just it's raining, that's true or not because either there is water falling from the sky or there isn't. There's some concrete material fact of the matter that makes it true. Conditionals are odd because they can be true without the antecedent being satisfied or the consequent being satisfied. So right now it's not raining and the sidewalks are not wet. Well, actually they're kind of slushy, but let's imagine. But the whole thing is still true, right? So what we do is we evaluate the truth value of the whole conditional, not really of its parts. Or at least what we do is say the whole conditional is true in this if whenever the antecedent is true, the consequent comes out as true as well. Philosophers get real weird about this. Actually, there's a bunch of different ways of analyzing the conditional, which I will not subject you to because it's not important for our purposes. But just note this oddness of the conditional. Note that the truth or falsity of it doesn't really depend on what's going on in the world. It's maybe depending on what's possible or what would be going on if the antecedent was true. And for that reason, I want you to resist the following temptation when we're mapping arguments. So resist the temptation to split conditionals up into two premises. I see this over and over again in people's attempts to analyze arguments. They take a sentence like, if it's raining, then the sidewalks are wet, and they'll make that into one premise that says, if it's raining, and then another premise that says, then the sidewalks are wet. And make them dependent leading to something. And those two things fail to be what premises and conclusions always have to be, which is propositions. Remember, these are always got to be propositions. So is it true or false that if it's raining? No. It is neither true nor false. The bit of the half of that sentence, if it's raining, is not the kind of thing that can be true or false. The only thing that can be true or false is the whole thing. If it's raining, then the sidewalks are wet, right? So resist the temptation to split conditionals up into two separate premises because you have to evaluate them as combined things, right? The conditional as a whole is a proposition. So here's a proposition. If it's raining, then the sidewalks are wet. That's a thing that you can tell whether it's true or false. Yeah? So this is a reasonable argument diagram. So if it's raining, then the sidewalks are wet. And you either give the antecedent as the other thing that is dependent with, or if we're doing modus tollens, we could do the negation of the consequent. So negation is just saying it's false that blah, blah, blah. So we could say if it's raining, then the sidewalks will be wet. The sidewalks are not wet, therefore it's not raining. That's modus tollens, right? So you're either saying yes to the antecedent or no to the consequent. Those are good ways of pairing something up with a conditional to make a dependent relation. But resist the temptation to split conditionals up into two separate premises, because then you end up with things that aren't propositions. Yeah? Does that make sense? Okay, so this particular meeting is slightly awkward because I'm giving you a whole bunch of rules that we're not going to practice until Wednesday. So I'm just like saying a bunch of stuff, and hopefully it makes sense in the abstract, but the point of this class is really not to absorb a bunch of abstract rules. So that's why we all have to get together on Wednesday and do some exercises. We're going to do in-class exercises where we try to translate this theory into skills. And that's why I've made the exercises, just completing them, part of your mark, because you can't cram skills. I know the temptation is always to kind of, I mean, it's week 2, so we're all still very eager to, do really well this semester. By the second month, we're all feeling like, I'll learn it all right before the exam. And that's fine if what you're trying to learn is just memorization stuff, but we're really hoping to develop your critical thinking skills in this class, which means you really gotta practice. Practice is the only way to get good at the skills that we're trying to develop. This stuff is, all I've done so far is theory. So we'll try to get some of this into practice on Wednesday. Every Wednesday we're gonna do practice or a test. So if this is feeling like odd and you're like, I don't know why he's telling me this stuff, that's because we haven't started trying to put it into practice yet. So if that's, hopefully, if you're feeling that way right now, that's what's going on, I suspect. I hope that's what's going on. Okay. So just to show you this diagram one more time, remember that we talked about this in terms of, when I showed you this, it was in terms of categoricals. Notice you can use the same way of thinking about it to deal with conditionals as well. So all ducks are birds, that's what this diagram says. If something is a duck, then it is a bird. Notice that works as well, right? So that rule, because this is a nice universal categorical, the rule of inference, if it's a duck, then it's a bird, works every time. Similarly, no ducks fail to be birds. So there's the nice negated version of this. There's no ducks that are outside of the circle of birds. And we can translate that categorical into a conditional. If something is not a bird, then it's not a duck. Yeah? Okay. So what we've learned so far is actually kind of the basics of argument diagramming. That's more or less what we're going to do for the rest of the semester. Like that independent, dependent reason stuff is kind of the last formal thing I'm going to teach you, sort of. All we're going to do from now until the end of the semester is practice this stuff and kind of layer complexity on complexity. So it'll end up looking kind of like this. This is a medium complex argument diagram. You can see there's probably going to be some dependent reasons. There's probably going to be some independent reasons. There's going to be premises justifying premises that justify conclusions, that kind of thing. You might end up with an argument diagram that looks like this from 100, 200 words of text, something like that. You might end up with an argument diagram that looks like this from 500 words of text or 1,000, depending on how finely you chop it up, right? So you can rephrase long-winded arguments in much simpler terms if you so desire. So this is about the level we'll be at by the middle of the semester, something like that. Just to show you something, how much worse it could be, here's a here's an argument diagram of Kant's critique of pure reason. This is upside down for our purposes. So this is transcendental idealism. That's the thing he's trying to establish. And each of these little boxes is like a chapter, a very dense chapter of his critique of pure reason. So the level of complexity could get here. This is like a 500-page dense philosophy book. But people really do use these techniques. So this is a professional philosopher using these techniques to try to understand the structure of really big, complicated arguments. I mean, we're aiming to get to the level where we can argument diagram a newspaper editorial. That's when you do the final written assignment, that'll be a newspaper editorial. I'll make you do an argument analysis on the exam where it's something that I've written, so it's kind of relatively easy to analyze. But people really do use this stuff in order to help themselves understand really big, complex arguments. So professional philosophy, what I'm teaching you is kind of this kind of skills that professional philosophers often use to sort of get clarity on how things are supposed to relate to each other. I'll just ask you to follow a couple of conventions when we're diagramming. Conclusions for us are always going to go at the bottom. Why is it that they go at the bottom? No reason, because I said so. Just so that everybody does the same thing. Yeah? There's no philosophical significance to putting the conclusion at the bottom. Just the top is the unjustified part, the bottom is the justified part. We'll just do that as a convention. In complex argument diagrams, it's sometimes necessary to repeat a premise. So we might have something like this. But premise 2 justifying. So premise 2 is justifying premise 1 and the conclusion. It's also a dependent relation with P3 to justify the conclusion. That's fine, so you can repeat premises as necessary. Here's what I would really like you to never do, and I'm horrified to say that I saw this on the final exam last time, so this didn't. People made it all the way through this class and failed to do this, but never do this. So we have premise 1, and people do the following. They just make premise 1, the arrow goes somewhere between premise 2 and 3. And for our purposes, this is gobbledygook. This says nothing. Yeah? For our purposes, this arrow is the justification relation. This arrow is supposed to be the reason to believe relation. And you need to tell me what specifically P1 is justifying. It can't justify just like this general area. Yeah? It's not just sort of like, it's justifying around here. Tell me specifically which, so you have to, if you think premise 1 justifies both of these, you can do this. You can say premise 1 has 2 arrows, one leading to P1 and one leading to P2. That's at least something specific. But if it just goes between 2 premises, then it's not anything. Yeah? So if I see people do that, I'll be like, I failed you, and you don't understand what this arrow is supposed to mean. Yeah? Okay, so those are, I mean, that one has a really good reason behind it. The other 2 are just kind of conventions, but they're conventions that I'd like you to follow so that we are all doing the same thing. Yeah, do you have a question? Okay, good. Okay, so that's it for today.